Welcome friends. Today we'll see the topic of ship power generation. This idea of this class is mainly to help for the ETO COC oral questions when the surveyor asks. And before starting, just to give a motive thought, end means not the end. In fact, end means effort never dies. So please put some effort. You will have clear the orals in the first attempts. So let's start with the ship's power generation. Okay, ship power generation. First we will see the just a outline of the description. Then detailedly we will go to the ship power generation. So if the surveyor asks about the ship power generation, there are two words we have to keep in mind. Of course, everybody knows the answer, but when the surveyor asking that time, we have to, in a way, we have to form a sentence, and with the appropriate words we have to use. So keep in mind the important two words, the alternator and prime mover. Shipboard power is generated using the prime mover and alternator working together. It's coupled together. The alternator works on the line principle, electromagnetic Faraday's law of electromagnetic induction. Whenever a conductor cuts a magnetic flux or a magnetic flux linking with the coil changes, and EMF is induced in the conductor. It's the main thing, okay? Then EMF induced there in this main we can say dynamically there are two induced EMF is there. Dynamically induced EMF or static induced EMF. Dynamically induced EMF, it is in the generator. Statically induced EMF you can see in the transformer. Here when you say and the magnet is moving in the coil, or when the coil is moving out of the magnet, and dynamically induced EMF is produced. Okay, what is the transformer? Then the magnetic domain is like this, and like this. The coil and the magnetic domain is stationary. So that the type of arrangement, statically induced EMF is by virtue of its change of its own flux. Okay, the changing of the own flux, it will create the induced EMF, statically induced EMF. This is just to tell about the induced EMF. Let's forget about this and go to the again to the okay. We know that the main principle of the electromagnetic Faraday's electromagnetic induction. Then we'll go to the magnitude. The magnitude of the voltage depends upon main three factors. Is the number of turns in the coil T, and strength of the field phi, speed at which the coil or the magnetic field rotates at F. Is the relative motion between the coil or the magnetic field rotates. See, there is a magnet and there is a coil. Yeah, flux is linking, the magnetic field flux is linking, but there is no change in the magnetic flux, so there will be no induced EMF. So there should be a relative motion between the coil and the magnetic field. Any relative motion exists, then only the magnitude of the voltage depends. Okay, then we will go to the main things. Okay, again, when you are explaining to the surveyor of the generations, they are expecting again the two words from you. The main thing is residual magnetism. We will see in detail in the next chapter about the residual magnetism. Okay, now these two words should be important: the residual magnetism and the prime mover. Residual magnetism and the prime mover. And before going into the detail, we just to go to the line diagram, so that will be very easy to go through. Just imagine, as we know, this is the main field rotor having the residual magnetism, weak magnetic field, and weak magnetic field is as the prime mover is rotating, cuts the conductor, and a small voltage will be induced in the stator winding terminals, and it's going to the step down transformer and giving to the AVR as input, and the AVR consists of a what you can say comparator. It compares to the voltage setting voltage compares and given to the amplifier, and the amplifier to the this is exciter stator. It gives the exciter stator. The exciter stator also has the residual magnetism. Here also residual magnetism arises, and the main field also the residual magnetism is arises. Okay, then this we can obtain the stationary magnetic field. Then as the rotor is rotates, the rotor also is excited rotor also rotates, it produces a three-phase AC and going to the bridge rectifier bank, and is given to the more flux to the rotor field. Now we getting what is the main field flux plus the weak already the residual magnetism. So both combines, which gives a more flux to cut and produce the more voltage, as the AVR gives supply up to that obtain the required 440 volt setting voltage. Okay, let's we see the point one by one in detail now. Okay, now the AC generator rotor has the residual magnetism, that is like a weak permanent magnet. When the rotor is driven by a prime mover, say a diesel engine, the weak magnetic field of the rotor cuts the stator windings and generates a three-phase AC in the stator. Okay, yeah, so the weak or low voltage is generated in the main stator. A part of the generator goes to the AVR, which converts the AC power to DC. This DC is fed to the excited stator. As you know, the AVR's automatic voltage regulator, maintaining the output voltage constant by regulating the DC current it provides to the AC excited stator. Okay. So finally, we get the DC supply to the exciter, given exciter also having the system. So we obtained a stationary magnetic field. We obtained is created in the exciter stator by the DC field to it. When the exciter rotor rotates, cuts the stationary field, so a three-phase AC is generated. Okay, finally three-phase AC is generated and is given to the generator rectifier bank. The rotating diode mounted on the shaft. The diode convert all of this AC to DC. This DC is the excitation of the main generator. So now what will happen? So the total field flux produced by the generator rotor is now increased. Total field flux due to the AVR and also the residual magnetism as a weak. Since the more flux now cuts the generator stator windings, a higher voltage is generated. This process of voltage built up continues until the rated term voltage 440 obtained. Thus the job for the AVR regulates the voltage to this value. That's it. In the way you can explain this. What you will say again, once again I will recall the points. Initially the main field having the residual magnetism. Because of this residual magnetism, as the prime mover is rotates, it cuts the stator winding and produces a small low output voltage and is given to the AVR. AVR compares with the setting voltage and given to the amplifier, and amplifier gives to the thyristor and given to the exciter DC supply and gives the given to the exciter stator, and this exciter stator will also produce stationary magnetic field. And now as the rotor is rotating, here the three-phase AC is produced and three-phase AC is given to the rectifier, and again the flux is increased and the more flux is cut, the output voltage also is increased. This is the same but in a different manner, the diagram shown down below. Okay, coming to the residual magnetism. Before going to the definition, we will see the magnetism, also overall magnetism. So, there is a two kind of natural magnet and artificial magnet. As you know, the magnetite and lodestone exhibits the magnetism property, and artificial magnet is a man-made magnet. This normally the alloys of an iron and nickel is a very poor magnetic property. But however, if you alloy it together, if the iron is alloyed together, provides strong magnets, and called as alkeno is a very famous. So what will happen when the material in the non-magnetic state has its molecular structure in the form of loose tiny magnets, like this random, there is electrons spinning in the random motion like this and like this, and so the nuclei is the nearby magnetism, and finally the total magnetism. But in this case, when the material is magnetized, the random arrangement of the molecule changes and lined up in the same manner, so exhibits magnetism property. Before that, we will see the different types of these the three kind of the paramagnet and ferromagnet and diamagnet. Diamagnet is we can see the example, diamond, antimony, bismuth, copper, gold. Copper gold also is a copper and gold is a diamond, because the materials that are not affected by the magnetic field, because the electrons spinning the orbits is cancel out each other, so there is no exceeds magnetism, so it is not getting affected. In paramagnet, what is the case is like the aluminum and platinum become magnetized in the magnetic field, but their magnetism disappears when the magnetic field is removed. Once you removed, then the magnetism disappears. In ferromagnetic material, that is what we using in the, you can see in the residual magnetism is exists in the ferromagnet. That's when I can retain the magnetic property when the magnetic field is removed. Even when you remove the magnetic field is removed, there exhibits a small alignment will be there in the material. This is called residual magnetism. Now we will see the definition. The amount of magnetism is left behind after removing the external magnetic field from the circuit, or the value of the flux density retained by the magnetic materials. The value of the flux density retained. Simply we can say the amount of magnetism is retained or left behind after removing the external magnetic field. This simply is the property of a material. It's the property of the core of the winding. Usually cold rolled steel will have a certain amount of magnetic flux remains even after the removing of the magnetic field. The area of the molecular magnet is called domain. Domain means just the magnetism alignment is called a domain. Some of the domains remains aligned over a small regions in the material once the magnetic field is removed, or the magnetism within the material will decay, depends on the material being used. So the ability of a material to retain its magnetism is called retentivity. You can just think of in relation solenoids, if you apply the supply, it will activate, and otherwise it will leave. It will not exhibits a magnetic property. That is the loose magnetism, quickly low retentivity. Example, the relationship. This is made of the soft iron core. That is what. And here the generator we have using the hard iron core. It will retain magnetism, high retentivity, permanent magnet. It is the alloys of iron. Even remove the magnet, the alloys of iron retain magnet. You can think why the diamagnet, paramagnet, why ferromagnet exhibits a residual magnetism. Because in every atoms, for many atoms, in terms of the electrons combination will cancel out each other. Suppose not so, and like this, each atom exhibits electron spinning which just cancel out each other, and the exhibits the magnetisms will do 0. But in ferromagnet it doesn't cancel out. So they exhibit a long range ordering phenomenon of the atomic level, which causes the unpaired electron spins line up parallel with each other, called a domain. So in ferromagnetic, the electrons produce a small magnetic field orbit of the nucleus, which exhibits in the same direction. So further, if you go in deeper, we can see in the BH curve. Okay, this will see the slide, will get more idea. So the diametric substance are those substances which are feebly repelled by the magnet. So nothing will happen if you keep suppose in the magnetic field you keep in the water. Nothing will happen. It is repelled. Only the less amount of the magnetic field is get affected because of the water. There's nothing will happen in the diamagnet. It's just repelling. When placed in the magnetic field, the lines of force tends to avoid the substance. Paramagnetic substances are those aluminum, chromium, is alkali and alkaline earth metals and platinum. The line of force prefer to pass through the substance rather than air. Here we have to see this chromium by atom is paramagnetic. Is actually chromium is antiferromagnetic. This we'll see the later. The ferromagnetic substances are those substances which are strongly attracted by the magnet. So iron, cobalt, nickel, gadolinium. The lines of force tends to crowd in the specimen. When a diamagnetic rod is freely suspended in uniform magnetic field, it aligns itself in direction perpendicular to the field. So when a paramagnetic rod is freely suspended in uniform magnetic field, it aligns in direction parallel to the field, and it is quickly aligned in the ferromagnetic material. Uniform magnetic field, okay. So this we can see the periodic table, and this all exhibits diamagnetic properties, and this is the ferromagnetic for this cobalt, nickel and iron. This is the BH curve. If we complete like this, we show exactly like this is going. Sorry, this is called, see now, if you increase the current, the flux is also increasing. Suppose you take this as current and this is a flux, is increasing up to the certain point. Even if you increase the further current, this will not increase. This is called permeability, they will say. If permeability is more, if you increase a small amount of current, there will be a more increase in the flux. So it's going like this and gets saturated. Even if you increase, there is no change in the flux. If you decrease, then the flux will come and attain here. This is called residual magnetism. See, the residual magnetism. After applying the negative, then it's going down, and again increasing, it is coming up. So only if you want to remove the residual magnetism, only by hammering or by increasing the temperature, the residual magnetism we can remove. So finally guys, this is only to give a outline to the questions of the ship power generation. As you know, what are the things you have to say? Just keep in mind the residual magnetism are given the lot more than the oral questions about the residual magnetism, and also the how the excitation is given to the alternator. Then just go through it and wish you all the best. And before that, I will also finish with the positive attitude. Everything the world has a beautiful end. If it is not beauty, be sure that is not an end. So keep trying until to get the best in the end. All the best guys, take care, bye.